And oops, sign in. Okay. Yeah, so we thought of covering this book, Machine Learning on Kubernetes. I hope all of you can see my screen. So this book basically covers how to use different machine learning or MLOps, or how to deploy machine learning operations MLOps on Kubernetes. That is the primary objective of this particular book. I just want to bring that main page of this. Let me kind of go back. Okay. Yeah, sorry. So this book is written by Faisal Masood and Ross uh, Brigoli. So what they did is when they published the book, which is I think a year and a half back, so that they used core Kubernetes, and at that point of time, they used a project called Open Data Hub. So Open Data Hub is a project uh, which basically kind of amalgamation of multiple different projects. It's like whatever is required to kind of um, uh, have the entire MLOps pipeline. It kind of bring all of those things together. And at that point of time, when they published the book, this particular Open Data Hub was we can run directly on the core or the vanilla Kubernetes. But in between, what happened is this is now supported only on OpenShift container platform, which is Red Hat's OpenShift container platform. So only on that, this particular ODH, whatever they call it, can run. So that was one thing which I thought of trying it out. So what I did is I basically took some time and installed ODH on the AWS. I took few machines, 4 5 machines out of the higher M1 large, and tried to set up, which was not so clean experience per se. How do you set up ODH, make everything work? But at the end, I could get partially working, but not the entire thing. So this book though talks about this as a primary thing, but the book also tells we can use this or something else as well to kind of perform all the labs of this particular book. What is mentioned there, right? That is one catch which we have to, one caveat which you have to be aware that we cannot use or we cannot follow the instructions as it is given on this book, which means, of course, there's going to be more effort need to be put in to run the labs or run similar kind of labs on Kubernetes directly. So that is one thing which you have to be aware. But being said that, what I also did is I basically went through all the chapters. I already kind of 75% finished the book, but just kind of reading purpose, not done any hands-on lab at this point of time. And I realized that, I mean, we can use core Kubernetes and perform all the labs, whatever are given there. So I'm pretty confident it can be done. But of course, it may require an additional effort, which I'm willing to pick up, take, and along with you guys as well, so that we can kind of uh, do all the labs on the core Kubernetes itself, and then see how we can take it forward. So what I have also done is I'll share this link actually on the chat and in the group as well later. I'll quickly share here. So anyone commented, right? Yeah. Okay, I'm putting this on the chat here, but I'll put it in the our Slack channel as well. So the idea is that if we kind of um, cover all of these topics, we are more or less done, right? And now there is more than one way of doing things. So first of all, few things are common, but of course, we can do few things differently as well. For example, the book talks about ML flow, but we can use Kubeflow. So earlier I was not too sure about whether we can use Kubeflow to perform all the labs of this particular course. But as I went through the content, I realized that we can use Kubeflow instead of ML flow, and what they have, um, something called as Airflow or something like that is there. So instead of that, we can use Kubeflow itself to do the things, but we can take that call a bit later, that whether we want to kind of follow exactly as the book says, like use ML flow and the pipeline what they are building with Spark and so on, or we can use Kubeflow. That all depends on how we progress in our book and what the interest level is. But of course, we'll finish in one way or another. So from this particular point onward, things may change, whether we continue with ML flow and the Spark way of doing things, or we use Kubeflow. So that's something which we'll decide as we as we kind of continue. But before that, whatever are there, so the book really gives a very good overview of different things, and also the example what they have taken, right? They have taken one end-to-end example to kind of take us through the entire process. I'll quickly talk about that. Yeah. So in the last few chapters, right, they really went in deep to kind of cover how we can look at the real business problem. Like for example, in this case, they have taken an example of a travel website which basically want to help their customer pick up the flights which are not getting delayed. So for example, if you log into a travel website and if you try to select some destination, right, it will tell you which particular flight would be on time in a way or less delay, right? So that kind of problem they have taken, and they have kind of went step by step process that how we can get the data, how we can clean it up, and how we can take it further. So that example is really good. So that is from chapter 9 onwards. But before that, they kind of covered the remaining part, the other part also in detail. Yeah. So any questions so far? Any comments?
Hey, Nipendra, I'm just wondering how many of us have access to this book?
Yeah, that's all the good point. Yes, correct. So how many of you have gotten access to this particular book? Anybody bought the book or subscription, something like that? So it's available in Safari and PackPub as well. So two of you. Yeah. Anybody else?
Yeah, so I've taken the subscription because it was economically more viable than buying the stuff. And I guess they have a good plan for 3 months. So
yes,
I think that should cover it. On Amazon, it is slightly costlier. I mean, way too costlier than packed. So, I mean, if you're interested, you should explore the subscription option.
Yes,
And
I did the same as well.
Book in like 3 months, right? I mean,
yeah.
Hopefully.
So we can finish. I mean, this book will not take much time because we'll be doing more practical per se.
Yes.
So I think 2 months, I think, should be good enough for maybe 8 sessions or 9 sessions would be good enough to finish the book.
I got a question, a more general question. How are we going? What kind of environment are you thinking of using? Are we going to have a shared environment? Are we each going to set up an environment ourselves and collaborate through comparison? I mean, how do you see that working?
So to be honest, I don't have an answer for that right now, but eventually we would. So a couple of ways to do it. First of all, maybe we can do all of these things locally, because if you look at the overall requirement for setting up Kubernetes, I think all of us can have a local setup, which I think most of you would have 16 GB plus machine with you. And we can do partially, I think, the thing locally, but I think once we pick up Kubeflow, for example, we may not be able to do it. So we'll see that at the point of time. So maybe if we can set up one instance which everybody can use at least during the sessions. That's good. One is also option is which came in the other group, that Civo Cloud is giving $250 worth of credits for Qflow right now. So where was it? Somewhere I saw, yeah, Qflow as service, right? In the beta phase, but still you get credits. So I don't know whether we'll go with Civo, with Qflow, or with MLflow. Then I think we'll kind of do that. But till then, till we setting up Jupyter notebooks, I think this can be done locally on our environment, and then we'll see how things will progress.
Okay, that's a good answer. So, obviously, most of us would have, access to a Kubernetes environment of some form, yes, on some cloud, and so we should, try and set up the basics just for familiarity, just so we're all on the same page.
Yep.
Up on that list, up to and including Jupyter Hub there. Yeah. But obviously, I think further down the track, if we had a shared environment that we could at least view or even contribute to, as a group, that might be quite productive.
Yeah, so what I was thinking is maybe we can have a Git repo in that we'll list down the steps as we go forward, so that it would basically help us do better, right? So we'll see how we progress. But the idea is to kind of, even if you're setting up locally, we can list down the steps, assuming that how do you set up the Jupyter notebook and so on. So there's good documentation already on the website, but we can just list down so that we can just quickly copy paste and get it done. So that is something which will kind of go as we go forward. So one thing, the way we have been doing this book club earlier is that we basically pick up a chapter lead per se, and the chapter lead basically leads the given session as well as whatever the labs and so on given for that. So something that we can also work here, but of course, as this is not going to be as straightforward as earlier, because we may not follow the book exactly as it is, because of course, something is outdated, something does not work, and as we try to adopt the Kubernetes only stuff, some things may not work. So there may be some additional efforts required. So if you can take that pain, we can work together, because I'll be definitely doing it. So if anybody want to kind of put down their kind of names against any of the topic, we can do that, right? We can take that forward and work together, right? And of course, this particular list of the item what I have done is not something which is finalized. If you think that there's a step missing, something is not in the right order, please put a comment, and then we'll try to rectify that and then come up with the entire good TOC of the things, right? So yeah, that's the idea. Any other comments?
Yeah, so I get. Sorry, I got one more. I guess. Are you planning to publish something out of this? I mean, you're going to update this book with what the approach that you're describing because it's more contemporary, or are you going to release a paper? I mean, is there a publication at the end of this, or is it?
Yeah. So to be honest, for me, the end goal is to kind of because as I know that I kind of train people on Kubernetes and ML stuff, right? So my personal goal is to kind of come up with a course eventually, which I can publish on my website. But for now, what we'll be doing is we'll be putting in a Git repo. What are the steps are required, right? We can put in a Git repo, which is open to everyone, and people can write down their steps, comments, and the steps what we're doing in the entire sessions, right? That's something which we'll be doing as we continue forward.
Yeah, it's exciting.
Great. Any other comments? Okay. Yeah. So yeah, go ahead. Sure. Yeah, correct. We have time.
On these things during these 3 weeks, and parallelly we keep updating ourselves, like what was our experience. I think by that time we will be able to decide whether it is feasible or not. Right?
Yeah. Right.
So in spite of waiting for each week, if we can jumpstart and try with that, I think the inputs from each one of us can help to move further.
For sure. That is why I said that if anybody wants to volunteer for a given topic, we can work together, right? Because to be honest, I am full-time currently exploring machine learning on Kubernetes, right? So we can work together and make the lab ahead of time, or what works or does not work, right? So if anybody want to volunteer for any of the chapters, please let me know or put your name against that. That would be great. Okay, so with that, let us kind of try to jump into the content part. So the way I thought of doing it is, of course, I have kind of have some notes which I've taken as we kind of as I kind of went over the book. So let me quickly bring them up. Bring it up. Yeah. So, but at the same time, what they have also prepared is, I think I've got it here. Yeah, this one, right? So they have also published a kind of a paper, not paper, I think a link which has all the PDFs, which I'll just not all the images there, right? Which kind of summarizes the stuff what I want to kind of cover. So I'll go with that, which would basically make things faster, and then kind of we can go back in the book and see what's missing there, right? So that's sort of my plan. That kind of cover the diagrams and then go over if any there's specific comment which I may have highlighted there. Right? Okay. Okay. So this is how the machine learning landscape looks like. Can you mute if you're not speaking? I'm getting some background noises. Yeah. Thank you. Great. Okay, so this is how the kind of a say how does AI, machine learning, and deep learning kind of interconnects, and I would also like to bring in the one more thing, right? Where it is. One minute. Yeah. So I think if we just try to combine this, it would be of great help. This is the white paper which we kind of went over already, but there's a specific diagram which I want to bring in here, right? So this is how things are connected, right? And this is also highlighted in this book as well, right? So we have on the top level, I think it's AI. Under that, we have machine learning as a field, and then we have a deep learning. That is how things are connected. So AI is like a superset of all the things. And if I look at this particular diagram here, hope it's visible to you. So if you look at here, this is how it connects with the overall maths and stats as well, right? So the machine learning typically is done with the help of data science team, where mathematician and other people work together to kind of get the sense of data. Basically, they would build the model, and those models we can then put down in the machine MLOps space and then make it run. This is how the intersection looks like: AI, machine learning, deep learning. And then we have this math and stats, and there is this common area, data science, which you call data science, where the machine learning or the AI stuff connects with the maths, right? So that is how it is, right? Anybody has more insights, like what kind of math or stats are required, which kind of makes data science work? Anybody is with a math background or data science background here? Or maybe the question is, why do you think math is so important in data science field? I mean, please just, I mean, it may be wrong, but please go ahead and share your thoughts. Ramkumar, I believe you may have some inputs. Yeah.
I think that data science is 100% related to maths, because we will be calculating some vectors, some metrics, and depending on that, we will predict something or generate something. So in the backend, everything is mathematics. This is why it's
Yeah, correct. Would you want to spend some more time if you have some kind of what is vector and why math is important? Do you have any example which you want to share, if possible? I'm not putting on the spot, but if you want to share some more inputs on that.
I have a separate view of mathematics and data science. So to give an example like this, I don't have one. So.
Okay, no worries, no worries. Anybody else want to try it out?
Yeah, probably I can try.
Please.
Basically, this vector thing is more on this dimension, like 2D and 3D things are represented using vector. So this will also help the computer to visualize and then maybe make these pictures or pixels or something like that to analyze into bytes or bits of the computer. So these mathematical statistics are mostly important for the data sciences to represent in a mathematical way, so, and
Yeah.
visualize things like that. Yeah, this is what I thought. It's been a long time, this mathematics.
Yeah, I understand. It's been a long time, and
Yeah.
that's true. That's true.
Yeah.
I started studying in the link chain, and
Mhm.
I use the flow-wise, and for vector I started building for my students the quadrant,
Mhm.
for vector storage, and I use LLM in I don't know what's the octar for Hugging Face, but I use the OpenAI for LLM too.
Mhm.
But I started studied. I haven't server but I don't have one big machine for using for room. I use a LLM for forever, but I have in my computer.
Okay. Okay. Yeah. So the question is why the math is so important, right? So I just want to brief, but I think I may come up with a better example next time. Though I have seen it, but I cannot explain it right now in a great detail. But I think that's a good point to kind of discuss maybe some other time. So in short, all the things with respect to um, uh, machine learning, right, is done with the help of mathematics. So think about whenever we are dealing with any word, right, or anything, any image or anything like that, right, we basically work in numbers, right? We don't work in plain kind of a say just like strings and text there, right? Eventually, when the data is being matched and being worked out, right, it worked out as a number, right? And we can represent those numbers in our coordinate system, 2D, 3D, and whatever was called earlier, right? And then for doing all that stuff, mathematics is very important. So just to kind of give an example, probability, right? So again, probability may not be used all the time, but we can take an example of probability and probability kind of a say computation and so on, right? As we kind of do our AIML work, right? So think about, let's say we take an example of, let's say weather itself, right? I know all of you heard about maybe Dubai weather, right? Last day or something like that, right? So now, what all would have cost that flood to happen in Dubai, right? Now there can be multiple reasons, right? The whatever the different, you can say, different parameters, right? And we can give weightage to each parameter. So for example, parameter can be cloud burst, parameter can be cloud seeding, parameter can be the near the whatever the wind is on the ocean. There are multiple parameters are there, right? So we can have all the different parameters, and we can give weightage to different parameters, right? And based on those parameters and the weightage what we have given to them, right, we kind of come up with some kind of reporting, right? Like for example, the department of metallurgy is kind of uh, not metallurgy, sorry, whatever the department that kind of does that, right? That what is going to be weather in the next few days or few months and whatever, right? So they have so many parameters and the weightage given to that, and they do some prediction on top of it, right? So for doing all that stuff, you require some kind of mathematics to be done behind the scene, because it simulate, right? So for example, if the wind is flowing at certain direction with certain speed and all those things, right? It can cause the rain for you at that given region. So to do all of those things, you require to do some simulation, and that is again, you can do some probability, right? So for example, if the wind was flowing with this, I can get rain and all that stuff, right? So and all of those things get represented in the mathematics. Now, once we have put down a mathematics there, what we can do is we can quickly kind of compute with the help of metrics. So matrix multiplications and metric operation would help us perform those things in a more efficient way, because matrix multiplication something which we can do very fast in these days, and that would help us calculate all the probabilities and all that stuff and give me the right result, right? So that is why we represent everything in mathematics format there. And why matrix? Because matrix, we can do matrix multiplications of different rows and columns, right? We can do in parallel. So if you have done multiplication of matrix earlier, right, you know that, right? We can take one row and one column to kind of get the resulting data, right? Or one column, one row, whatever it is, right? So that is how we can do that, and that all of those operations can be done in parallel. By doing that, we can calculate our result very fast, and that is why the GPU becomes handy, right? So and why GPU? So earlier, as you know, GPU is graphics processing unit. So GPUs were primarily built for gaming purpose, because if you have played any game, right, you know that, right? You can move your cursor, go left, right, up, down, and all those stuff, right? And think about, you are living in that dimension, three-dimension space there, right? And when you move your mouse to go left and right, you need to have a new view, right? And that new view is calculated based on the multiplication of matrix. That is how they have been done. So earlier GPU were built only for doing the gaming purpose, but when it is thought we can do deep learning and we can combine this multiplication of matrix. And now why GPU? Because GPU can perform matrix multiplication very fast. Because as you know, in GPUs we have, think about multiple CPUs, because our regular CPU can do one job at a time. But if you use GPUs, you can have multiple cores inside it, and those cores can perform operations in parallel. And that is what the benefit of using GPUs, because GPUs can perform matrix multiplication very fast, correct? And that's the whole idea why GPU and the data science has come together, deep learning has come together, because we can represent any of our problem which you want to predict or emulate, right, in the matrix in a much more in an effective way. And that is what the marry of GPU and the data science has come together. Hope it makes sense. Any questions?
layers also, this type of processing will really help, because when we discuss mainly about this machine learning and other aspects, we will be having different neural networks, right? So to add those values together, these matrices and GPU will play a major role.
Yeah. Okay, great. So let's kind of go back here. Yeah. This is how the things come together. Now, if you look at here, this is what they're talking about, what they have mentioned about the entire pipeline of MLOps, right? Now, if you look at the entire stuff, right, ML plays a part, but is not a significant part of the entire process, right? Because machine learning is a part of the entire pipeline, and in the pipeline we have different things, right? For example, configuration, data collection, data verification, feature extraction, machine learning, resource management, analysis tools, serving, monitoring. So all of these things, when it comes together, right, then basically it becomes MLOps, correct? Or not, I would say MLOps, the entire process of the machine learning thing, right? It's not just that you run a model and you get some output. That, of course, is kind of part of it, but not the entire thing, right? Because to do anything, we require, first of all, the very good quality of data. If the data is not good, we cannot perform anything. There is a saying, right? Garbage in, garbage out. So if you don't give the right data set for your model to kind of get trained on, right, it will give you some random data only, right? So I think that we have seen some example of that already with Google. I think they have done some model training based on some specific group of or ethnic groups, right? And then, but the data was coming in different group. So, I mean, we can understand that as we continue forward. But the main part is the data is the key part. So, if you don't have a good data to train on, you cannot get the right output. So, for example, if you train the ML model with, let's say, only Asia people, right? Asian people, right? And if you try to run this model for the other countries like America, US, right? Then the kind of say the response you would get will not match the expectation of the end customer there, right? Because the behavior of Asians may be different than the behavior of the US folks, right? So when we kind of build those ML models, we need to be careful what data we are using to do that stuff. And that is why data collection and data verification and those things play a very important part. Anybody want to pick up any thoughts on that? Like what behavior you have seen that you have got the wrong data or wrong output, right?
Well, I guess not exactly, but I guess I just add there's variability in terms of data sets. So of course, there's always a plus or minus. It depends on the nature of the data we're talking about, obviously, whether it's scientific or whether it's subjective. But of course, there's always variability in a model, and it's difficult and interesting to try and articulate and measure what that variability is. That example you gave with Asian people versus American people or whatever that is quite a clear example. But sometimes data comes with inherent errors and vagueness and unknowns within it. So as part of data science and from a scientific statistical basis, it's very important to be able to measure that variability and be able to manifest what the risks are, if you like, associated with a particular not only data set or model but outcome. So a model could do certain scenarios really well. It's kind of the core context, and other scenarios that are slightly on the fringes and boundary conditions, are going to have increased issues with the data.
Right. So there are different personas who would work on different part of the entire process, which was also mentioned in that CNAI document as well. You can go over that. We kind of cover that in the previous meetings. But with the book perspective, right, they have also given different personas here. For example, data engineers are the people who are going to work to make sure that we got the right data. We did a verification of that. We did some cleaning on this, and so on and so forth, right? So data engineers' job is to basically get all the streams of the data, maybe from live data, from data lakes, or wherever it is, right? Data, whatever is coming up for the ML workloads, right? That is right. So that data engineers are the one who is responsible for data collection. Data collection may not be that much because it will be done on the field as well. But once data is given to them, they need to kind of make sure that it's in the right format, it is cleaned up. Then you have to handle situations like that when, let's say, there's a missing data, for example, right? So, for example, let's say you have given a physical survey to be done in your villages or whatever, right? And then because of the rain, certain fields are not visible correctly. Now, what happens in that case, right? Because the data is not kind of there which we want, right? So we need to predict some data, or we need to kind of assume some data what has to be there to make this particular field come in, right? So data is always going to be very unstructured, may not be complete, and so on and so forth. Data engineer's job is to get the data, do the cleaning of it, put them in the format which we can feed it to the pipeline of ML. Yeah. So that is the job of the data engineers.
And sorry to interrupt, I would like to give a scenario as well, add on a scenario. So recently I have participated hackathon wherein I was trying to do sales forecasting using footfall model. So I have used profit model with the help of footfall data. So I have used the historical data, but since during it's of COVID period, like there was no seasonalities, or you can say consider discounts that was ongoing. So I have missed that data. So once I have added the seasonal data, then the forecasting gave a different output. So this is one scenario where data is plays a major role.
Yeah. So I think a lot of weightage needs to be given for the data part, right? So people talk about models, we talk about serving and all those things, right? But the data is going to be the major part, and data is, I would say, the king, right? See, all the enterprises have a lot of data. For them, it makes sense to kind of build the models and all those things, right? For example, for a startup where they don't have last year's data itself, right, which is just like some data, right, you can't do much about it, right? So only the big companies who have been sitting on the data for a long time, they can now harness it, correct? This is the tool which they are really kind of waiting for eagerly, right, to kind of harness data what they already have for so long, right? For the new companies, of course, they can do some magic to kind of generate some data and from other companies and kind of do something there, right? But it would not be the real data what big enterprises may already be having, right? So I think big enterprises are really going to benefit out of the entire AI/ML space there. Yeah. Okay. So that is there. Now, once we have the data, then the next process may be for, I think there is one more picture. Yeah. So, yeah, this is a one more picture what is being mentioned here, right? So let me. Yeah. Okay. So once we got the data, we would do a cleanup on that and so on, right? Then we are a data scientist who would basically take out that cleaned up data, and they would basically create the models. Suppose we'll create a model later down the line, but those are the guys who are going to build the model for us. And then they would build a model maybe with a small data set. Then eventually they would kind of build or have a process where we kind of create these large models and so on. So what happens once you have data, right? We can divide the data into three sets. One is a training set through which we train our model. Then we have the production, or you can say the test data set. For example, I have taken whatever 1 million data point I have taken. Out of that, I can take 70% as my training data. Once I have trained my model, then I can use some data, whatever the output we get. So once we have trained our model, we can take, let's say, remaining 20% of data to basically check what is the accuracy of the model is, right? So that way we can be sure that, okay, whatever model we are building, it is actually able to predict something if we give the similar, or what you call, say, a similar kind of a scenario data, right? So we know that, right? Because let's say if this happened, something happens for sure, right? And I have the point to prove that, right? So what does this model do is it try to kind of make sure it predict the next step, right? Whatever is going to happen, right? In a way. So if I have trained my data with my real data set, I can use part of it as a training or as a test set, right? Which I would eventually get the accuracy of my model. And once I am comfortable with the accuracy of the model, I would then deploy in production and take it forward for the production workload. Make sense? Okay. Fine. So data scientist kind of would do that part to build the model. And of course, data scientists would need to work with the domain experts, right? Because data scientists may not be domain experts. So, for example, if I talk about crop management or vehicles, or let's say turbine management, or let's say dam, whatever it is, right? Data scientists may not know all the fields, right? So they would work with the domain experts to kind of build that model. So if I know that, right, for sure, right, if I for the crop management, for example, right? So for example, if I know to grow the chili, I require a lot of, let's say, magnesium. I'm just putting a thought. I'm not too sure about that, right? So if I know that, okay, if in my soil I have right amount of magnesium, the chili would grow well. So that's something that scientist may not know, but domain expert would know. So if I, let's say, if I take my soil data and give it to my model can then say what you can grow in this particular soil, right? Or what you have to add in this soil to make it rich for the growing chili, whatever it is, right? Domain experts are going to play very important role with data scientists to build the model, right? So domain expertise is required, is a must to build the model. Otherwise, so there are some tools are available like AutoML and all those things which can build the models. But of course, to build a really good model, you will require domain experts to be available with you. Then we require IT operations, like in this case, you can say MLOps engineer or SREs with ML knowledge and so on, right? They would basically build the infra to serve the model. And of course, before serving, they would build the process like a CI/CD for ML. So when the new data comes up, I need to rebuild my model and redeploy it for the new requests which are coming in production, right? So that entire stuff need to be handled by the MLOps, which I think the main theme of this book. So we'll go in detail of that. And then we'll have app developers who are going to basically consume the models which are being served and then build apps on top of it. Correct? That is what the app developer would be doing. Correct? Yeah, so I think that's kind of time what we have for today. Any thoughts or anything you want to add at this point of time? Okay. Anybody thought of volunteering for any of the part of this thing, right? So I would highly recommend that you go over this flow, spend some time, and if you have any ML expert, MLOps expert within your team, please have them review this. Please add comments that what things we can add here. I mean, if you want to expand on this, please feel free. That would be highly useful for every one of us. Yeah, so that's all for today. Next time, we'll try to kind of wrap up our basics, and then maybe look at a demo of a Jupyter notebook. Let's see how much we can do. Yeah, I think that we should be able to do pick up because Kubernetes, I think basics all of us know. So we'll start with cover these basics and try to bring up a very small Jupyter notebook to take it. Yeah.
Yeah, that sounds great, Nipendra. And I think this is a good start to this new book.
Sure, great. Anyone else has any comments, feedback?
You know, I have a short question. So if you go back to, if you scroll down a little bit, and the next diagram. So I don't know if it's a typo or something that I have changed when I studied, but in the data science figure, you can see that is ELT rather than L. So it's
right.
It's extract, load, and transform. Normally, it's extract, transform, and then load in order to.
That's okay.
So I was wondering if something have changed or is a typo. I don't know.
Maybe typo. Maybe because whomsoever, I mean, people can read it different. But yeah, that's same ETL, ELT, whatever you want to call it. Yeah.
Okay. Yeah, that's all. Thanks.
Okay. Then we are, I think, good. And of course, please feel free to basically share about this book club. Let others, friends, join in and so on. Spread the word. And I would highly encourage, please be consistent so that the flow is there, and then we can really get really good things out of it. Yeah. Okay. So that's all from my side. We'll see you guys next week.
Okay.
Yeah,
Good one. See you next week. Bye.
Bye bye.
Cheers.